Hey everyone, so this is the next section in chapter 7. Chapter 7 is all about polynomials, right? So 7.2, we start to talk about how we are going to combine polynomials by adding and subtracting them, okay? So adding and subtracting polynomials is similar to combining like terms. We've been doing this all along, guys. Combining like terms. This isn't a new skill, right? We've done this so many times before. And it's just how we add and subtract polynomials, how we combine two polynomials together. A big thing that we need to remember, and we always get messed up on, is when we subtract, you must remember to distribute the negative, okay? And that's going to be a common mistake that I see a whole bunch. And so we're just going to be careful. When we subtract polynomials, remember to distribute the negative really to the second polynomial is really important in there. The polynomial that we're subtracting. Okay, so let's check some of these out. Find the sum of the polynomials, so we're adding. Guys, all this comes down to is combining like terms. When we add, we really can write this right away without parentheses. So I can say 5x squared plus 2x plus 1 minus 4x squared. I don't need to have two signs there. Minus x minus 2. I don't have anything, nothing changed. I literally just rewrote this without the parentheses, okay? Adding, we combine like terms. And now we're going to look for our like terms. So I'm going to have 5x squared minus 4x squared. That gives me x squared. I have 2x minus x. That gives me x. And then plus 1 minus 2 gives me minus 1. And there's my answer. Notice how I underline the terms, the like terms, to combine them, to know which ones combine. Notice which ones can combine, okay? The ones that have the same variable and the same exponent. Let's check out B. I'm going to rewrite this without the parentheses. Nothing changes. Negative AB plus B plus 3AB minus A. Now we combine like terms. I've got negative AB plus 3AB. That gives me 2AB. B doesn't have anything in minus A, so I don't have any terms to combine. We just leave it as is. Okay. Now let's check out problem 2. This is when we are subtracting. So this is where we have to remember to distribute the negative. Notice when we write this without the parentheses, this one stays the same. And now we have to distribute that negative to everything inside this parenthesis. It's going to be negative 2y squared plus 5y plus 3. Opposite signs. That's pretty much what happens, right? Because when you times it by a negative, you either make it a positive or a negative. And now we combine like terms, continue like normal. So I'm going to have y squared minus 2y squared. That gives me negative y squared. 4y plus 5y gives me 9y. 2 plus 3 gives me 5. Okay, let's practice subtracting again. First polynomial stays the same. Second polynomial, we need to distribute that negative. So 2b squared is going to become negative 2b squared. B becomes negative b. A becomes negative a. Negative 4 becomes positive 4. All of those signs change to the opposite sign. Let's combine like terms and put it in standard form. We need the greatest exponent in the front. So that's going to be this negative 2b squared. And then this guy has two terms, so that is next. Plus 2ab gets written next. It's a positive 2ab. Minus b minus b, that becomes negative 2b. A minus a, that's 0, plus 4. Okay. Now we are going to practice a couple more here. These types of problems, notice they give us three functions. They give us f of x, g of x, h of x, and we have to add and subtract whichever ones they tell us. So it says f of x. So I'm going to go grab f of x. So that's going to be 4x squared minus x plus h of x is 5x plus 2. Okay? It's addition. I'm going to rewrite this without the parentheses. Nothing changes. And now I'm going to combine like terms. 4x squared is by itself. Negative x plus 5x is plus 4x plus 2 at the end. Okay, and then we can check out b. F of x is 4x squared minus x, minus g of x is negative x squared minus 1. Going to rewrite this without parentheses, remembering to distribute this negative. First polynomial stays the same. Negative x squared becomes a positive x squared. Negative 1 becomes a positive 1. Write this in standard form. 4x squared plus x squared is 5x squared minus x plus 1. Nothing can combine with those. Okay, great job, guys. Let's check out some word problems here. The first one says, a farmer must add the areas of 2 plots of land to determine the amount of seed to plant. The area of plot A can be represented by 3x squared plus 7x minus 5. Plot B can be represented by 5x squared minus 4x plus 11. Write a polynomial that represents the total area of both plants. So we are going to add these two polynomials together. 3x squared plus 7x minus 5 plus 5x squared minus 4x plus 11. Combine like terms, looking for the greatest exponent first. That's going to give me 8x squared. This is going to give me 3x. And that's going to give me 6. Watch your signs. Be careful. Great job. Let's check out problem 5. The cost in dollars of producing X toothbrushes is given by the polynomial 400,000. Oh, it should be here 40,000 plus 3x, and the revenue generated from the sales is given by the polynomial 20x squared minus 4x. All we need to do is write the polynomial that represents the profit equation. That's what A says. They give us our profit formula. Profit equals the revenue, which is this equation, minus the sales, which is this equation. They give us that equation, we plug it in, and we simplify. Remember our first step, distribute the 40,000. Then we need to combine like terms. 20x squared is the highest exponent, minus negative 4x, minus 3x is negative 7x, minus 40,000 is my profit. What is my profit equation? This is my answer. Okay, we needed to be given that formula. I wouldn't expect you to know that formula. That will help us just substitute in what we need to know. If they make 2,000 toothbrushes, what is the profit? All we need to do is substitute 2,000 in for x. And we can put this right into a calculator. And we should get 79,946,000. Okay, right into a calculator, guys. You can type that in. Awesome job. One last word problem for this section. So it says the number of gallons of water in a leaking pool is determined by the rate that the water is filling. This is the rate the water is filling. And the rate the water leaks is given by this polynomial. Write an expression for the net change in gallons per minute of the water in the pool. Okay, so here we've got our equation. It's going to be the change in the gallons. So we can say change in volume. And so what that's going to be has to be how much it's filling minus how much it's leaking. And that's going to be our equation, right? Because that's how much is going to be left. How much it's filling minus how much it's leaking. So I'm going to have filling is 8g squared plus 3g minus 4 minus how much it's leaking, 9g squared minus 2g minus 5. Okay, I'm just going to come down here, write this by distributing that negative, the subtraction. combine like terms. I've got g squared and negative 9g squared gives me negative g squared. 3g plus 2g is 5g. Negative 4 plus 5 is plus 1. There's my equation for the change in the volume. Find the change in the amount when the rate is 5. That's our g. So I'm going to say the change when it's at 5 is negative 5 squared plus 5 times 5 plus 1. We've got negative 25 plus 25 plus 1. It's going to be 1 gallon per minute. Okay? All right, great job. We're going to do lots of practice on adding, subtracting polynomials, and check out some more word problems. Awesome job, guys.